Good morning children. I am Hema Kumari, Physics CRT in atchutapuram kgbv. Are you preparing well for exam? Next month onwards they are going to conduct exam. Do you know that? So prepare well. After preparing you just write that on a paper and correct it properly. Then only you will get good rank. Okay. So in a previous class, his teachers told about a model paper, so I won't repeat it once again. But while writing the exam, you just write the answers point wise. And if diagrams are there for the experimental questions, you draw the diagrams and label the parts, and that one you just keep it in a box. And presentation is very important in exam. If you present that in a proper way, a point wise and neatly, you will get full marks. So that you have to remember. And let me start our revision part today. So this is a very important topic and you will get more marks from this. What is that? You know, that is atomic structure. The first important topic in this atomic structure is Bohr's atomic model. What he proposed in this atomic model. So to explain this model, I need to draw one diagram like a nucleus at the center and orbits around the nucleus. So what his first proposal? Electron occupies stationary orbit. Electron in an atom occupies stationary orbit. What is the meaning of stationary orbit? You know, stationary orbit means as long as electrons revolves around the nucleus, it doesn't gain energy and doesn't lose its energy. That is the meaning of stationary state. Here they may ask you what is meant by stationary orbit. Okay, and one more here, what is meant by orbit, they may ask you. So this is very important question and it is repeated many times. What is meant by orbit? Orbit means the path. This is the path, no, in which electron revolve. The path in which electron revolve. Here first one is electron occupies stationary orbit. Electron occupies stationary orbit, and the stationary orbits are at different distance from the nucleus. Yes, no? So first orbit distance is different from the second and the third one. So these are at a different distance and the energies of these stationary states are different. Okay, and second proposal. Second one is when electron jumps from lower state to higher state, it gains energy. It gains energy. Gaining means it absorbs energy. And when electron jumps from higher to lower, higher state to lower, it emits energy. It emits energy. How to remember this point? You know, when you are going from lower class to higher classes, you are gaining some knowledge. Yes, no? So from first standard to 10th standard, you are gaining some knowledge, no? In the same way, when electron jumps from lower to higher, first to 10th class, you are gaining. Here too, when electron jumps from lower state to higher state, it gains energy. In the same way, when electron jumps from higher state to lower state, it emits energy. So the best example to remember this point in the class, if anyone are losing ranks, means they are day by day they are losing their knowledge. Here too, when electron jumps from higher to lower, it emits energy. That is the second proposal stated by Bohr. And third one is the energy of an electron in an atom is quantized. So electron energy is quantized. Quantized means its energy is fixed. Its energy is fixed, and corresponding to these energies are E1, E2, E3, and the stationary states are energy stationary levels. So these are the proposals proposed by the Bohr's atomic model. This Bohr's atomic model successfully explained the hydrogen atomic spectra. But few failures means few limitations also there. That is very important question. So only 2 points are there. It may come for 2 marks. So first failure is the Bohr's atomic model failed to explain the atoms, the atomic structure of atoms which are having more than one electron. Means it is successfully explained the atomic spectra of hydrogen atom. So that's why in your textbook they gave Bohr's hydrogen atomic model. They gave Bohr's hydrogen atomic structure. So this model explained successfully the atomic structure of hydrogen atom, but it wouldn't explain the atomic spectra of an atoms which are having more than one electron, and also couldn't explain the splitting of line spectra. Next important topic to us, quantum numbers. So this is very important, and that is repeated many times in your exam. So like 4 marks questions, 2 marks, 1 mark, and even half mark also will be covered. So let me discuss about these quantum numbers. Actually, these quantum numbers describes the position of electron in an atom, position and the orientation of electron in an atom. These quantum numbers are actually 4 types of quantum numbers. Principal quantum number, angular momentum quantum number, or we can call this as azimuthal quantum number also. And third quantum number is magnetic quantum number. And fourth one is spin quantum number. That is not there in your chart, but let me discuss about spin quantum number later, after discussing about these 3 quantum numbers. So in your exam, how to write this long answer? For that, I will give few clues how to write this answer. So first point is who proposed, and second one is, so with which letter we denote this quantum number, and third one is what information and what it describes, what information it gives, otherwise what it describes, and fourth one is about values and other information. So like this, if you remember, then it is easy to you to write in the exam. So first let me see who proposed this principal quantum number. So principal quantum number proposed by Niels Bohr. Who? Niels Bohr. Angular momentum quantum number proposed by Sommerfeld, and magnetic quantum number proposed by Landy. Spin quantum number proposed by Uhlenbeck and Goldsmith. You don't worry, I will write it later. And so this is the first point, who proposed, that is the first point. And denote. So principal quantum number denoted by N, and angular momentum quantum number denoted by L, and magnetic quantum number denoted by ML. With which letter? ML. And now let me discuss third point, which information it gives, what it describes. So it describes about size and energy of the shell. Shell means that is an orbit. You know what is meant by orbit. That we discussed in Bohr's model. Okay, the path in which an electron revolves. So it describes the size and energy of the shell or orbit. Now coming to angular momentum quantum number. So what it describes means which information it gives. It just gives the shape of subcell. So in the orbit subcells are present. So shape of this subcell it describes. And next one, magnetic quantum number. Magnetic quantum number it describes about the orientation of orbital. Orientation of orbital. So that is the information. So next one is about values. N increases. As N increases, the cell size and energy increases. Here application mode questions will come. So how it is, let me discuss. See here, fourth point, as N increases, the shell size and energy increases. For example, if N is equal to 1, how many orbits are present? Here N represents the orbit or main shell. N is equal to 1 means in that atom it having only one orbit. So this is the nucleus. Around it one orbit only present. If N is equal to 2, then how many orbits are present in this atom? So around the nucleus 2 orbits are present. Once compare these two atoms. Here the atom which is having only one orbit is smaller than the atom which is containing 2 orbits. Means size is increased here. Yes, no? Size is increased here. Means as N increases. Here see, N increases than this. So when N increases, the size and along with that energy also increase. So in Bohr's model we discussed the orbit which is nearest to the nucleus having lower energy. So N is equal to 1 having lower energy. So the first orbit Bohr named it as K, and second orbit he named it is L. So like that, if N is equal to 1, that is K shell or orbit. If N is equal to 2, that is L shell. If N is equal to 3, that is M shell. N is equal to 4, that is N shell. So like that, in the exam they ask you which shell having more energy. Which shell having more energy. Here once you observe this, N is equal to 4. Here the number N is equal to 4. N represents number of orbits in the atom. Here N is increased. N is equal to 4. So this N shell having more energy compared to N is equal to 1 or N is equal to 2 means L shell or N is equal to 3 means M shell. Otherwise they may ask you what is the name of the shell if N is equal to, what is the name of the shell if N is equal to 3? What is the name of the shell according to Bohr? First orbit is K, second orbit is L shell. So third orbit is M. Like that also they may ask you in exam. Okay. So this is about principal quantum number. And here this fourth point directly they are asking as a half mark. As N increases, what happens? So the cell size and energy also increases. Like that also they are asking. This is very important topic. Now coming to angular momentum quantum numbers. What are the values that it takes? So L takes the value from 0 to n minus 1. 0 to n minus 1 means maximum value for L is n minus 1 for given n value. So here L is equal to 0 means it represents S subcell. If L is equal to 1, that is P subcell. If L is equal to 2, that is D subcell. So what is the name of the subcell? D subcell. If L is equal to 3, that is F subcell. So in exam they are asking, if L is equal to 1, what is the name of the subcell they are asking? You know L is equal to 0 means that is S subcell. So L is equal to what is the name of the subcell? If L is equal to 2, that is D subcell. So here otherwise they are asking what is the L value for F subcell, they may ask you. So in a reverse mode, for F subcell, so the value of L is equal to 3. Otherwise they ask you what is the maximum value of L if n is equal to 4. If n is equal to 4, what is the maximum value? You know this formula. L takes the value from 0 to n minus 1. This is the maximum value for L. Yes, no? So if n is equal to 4, so the maximum value according to this, you just substitute 4 in this. Then what happened? 4 minus 1, 3. So L takes 3 values. Next one. So like this they ask you in the exam. And coming to magnetic quantum number. Here see. So ML has integral values between minus L to plus L including 0. And for given L values, ML has 2L plus 1 integer values. ML is taking minus L plus L including 0 they are saying. So we know in maths teacher draws number line and how she represent the integers. So first negative numbers and 0. So later it is followed by positive numbers. Yes, no? Negative numbers, 0, positive numbers. Like that only here too ML takes the values minus L values 0 and plus L values. So for given L values, here last point, for given L values ML is taking 2L plus 1 values. Let me see that. For example, L is equal to, for given L value, L is equal to 0. Then ML is taking, according to this formula, just substitute L value in this. 2 zeros, 0 plus 1 means 1. Means ML is taking 1 value. That represents subcell S orbital. That is S orbital. Okay. And the next one. For L is equal to 1. How many values that ML takes? According to this, just substitute L value in this. 2 into 1. 2 plus 1. So how many values? 3 values. ML has 3 values. That means, so 3 values. How can we write? Minus L, 0 plus L. Like that only we have to write. First of all, you just write 0. Here negative numbers and then positive numbers. If you write like this, then it is easy to you. So here these are p orbital, px orbital, py orbital, pz orbital. Okay, s orbital. So I am taking one value, that is s orbital. Shape of s orbital, you know. What is the shape of s orbital? That also a very important bit. That is repeating many times in our exam. So s orbital shape is spherical shape, and once you practice the orbital diagrams also. So s orbital shape is spherical shape. Now coming to these three orbitals, these are dumbbell shape. Dumbbell shape, px. So px, this is px. So py is like this. So on y-axis, and this is pz orbitals. So this is pz orbital. So py, so that lies on y-axis. Px, that lies on x-axis, like that. So these s and p orbital diagrams are very important. So coming to L is equal to 2. L is equal to 2. L is equal to 2. So for given L is equal to 2, how many ml values will come? According to 2L plus 1, 2L plus 1. So substitute in this, 2 2s are 4 plus 1. How many? So 5 ml values. 5 ml values. How can you write this 5 ml? First what I said, 0 you write it. And here this side minus 1, this side plus 1. So totally 3 over. So next two values, like this if you write, it is easy to you. So ml is taking 5 values. So those are these orbital. It represents orbitals like dxy, dyz, dx square, y square and dz square, like that. 5 orbitals will come. And one more important bit here, how many electron can exist in the orbital? How many each orbital? For example, s orbital is there. Where it is present? So in the atom, in the first orbit, it containing s orbital, 1s. In the second one, it containing 2s and 2p orbital. And in the third one, how many subcells are there? 3s, 3p and 3d subcells are there. So in the first orbit, it containing only one subcell. So in this, only one orbital is present. So in one orbital, maximum 2 electrons can exist. So that's why in the first, in s orbital, only 2 electrons can exist. And coming to p, so p having 3 values. Now only we discuss, like px, py and pz. So in each 2 electrons, totally 6. It containing 3 orbital like px, py, pz. 3 orbital it containing. 3 2s are how much? 6. So in the same way, d orbitals, coming to d. So how many values? ml is taking 5 values, no? 5 values. So means 5 orbital. It represents orbitals. 5 into 2. How many? 10. Okay. So 10 electron can exist like that. So depending on the ml values, how many electron can exist? So for, I will write it once again. S is equal to, S is taking only one value. It is taking only one value. Means 2 electrons only can exist. So ml value is 1. So next one, for this is for s orbital. S orbital. For p orbital, ml is taking how many values? It is taking 3 values. Means 3 2s are 6 electron can exist. So third one is d orbitals. For d orbital, Mn is taking how many values? 5. Means 5 orbitals are present. 5 into 2, 10 electron can exist. And in the same way, they are asking how many maximum number of electron can exist in each orbit. They are asking in each orbit. So you know. So in the first orbit, how many orbitals? Only one s orbital is present. Means in s orbital, now only we discussed how many electrons can exist. 2, no? Means, but Bohr gave one formula to that. That is 2n square. This is very important, Nana. So you have to remember this. Maximum number of electron can exist in each orbit is 2n square. According to this rule, let me check. So 2n square means 1 square. So 1 into 1, 1 only. So 1 into 2, so totally 2 electrons. See here, in the first orbit only one orbital, 2 electrons only can exist. Coming to second. So you know, 2 orbitals are present in this. See, according to this 2n square rule, 2 into, in the place of n, second orbit, no. So you keep 2. So 2 square, 4 2s are how much? 8. So 8 electron can exist. You know, in P, 3 orbital, Px, Py, Pz, depending on the nml values. So 3 2s are 6 electrons, and in S, only one value. So means only one orbital is there. So 1 into 2, 2. So total is 6. This is 2 plus 6. How many? 8 electrons. So like that, number of electrons present in the orbit, that gives 2n square. That gives 2n square. This is also very important. Next, coming to last, I said I will say at last, spin quantum number. Spin quantum number. So spin quantum number. First, what I said? Who proposed? So that is Uhlenbach and Goldsmith. So with which letter we denote? Which letter? It is represented by MS. And what information it gives? It gives the orientation of electron. Orientation of electron. What values it takes? It takes the values plus half and minus half. So anti-clockwise direction and clockwise direction. Okay. Next important topic is electronic configuration. First, what is meant by electronic configuration? Electronic configuration means distribution of electrons in shells, subcells and in orbitals. Shells means orbits. Okay. So distribution of electrons in shells, subcells and in orbitals called as electronic configuration. Here in exam they are asking what is this? Means it's a notation for electronic configuration. Here n represents principal quantum number, means represents shell, main shell, and L represents subcell. So S subcell, P subcell, D subcell, F subcell, like that. X represents number of electrons. In exam, they are giving this notation and they are asking what is meant by N, L and X they are asking. Otherwise, in a reverse way also they are asking. Let me see one example. Helium. You know atomic number helium 2. How we can write the electronic configuration? 1s 2. Yes, no? So helium, in helium 2 electrons are there. 2 electrons will be filled in s orbital only. Why in s subcell it containing only one orbital. It containing only one orbital. How you know? Now only we discussed quantum numbers. It's ml values. We calculated na ml values. ml values. So ml formula 12 plus 1. Yes sir. Yes sir. For yes sir. L value 0 no. 2 into 0. For s orbital, L value, L is 0. For s orbital. So just you keep 0 in the place of L. 2 into 0, 0. 1 now. So ml take 1 value, means 1 orbital only present. Now, and I said in 1 orbital how many electrons will be filled? 2 electrons. So according to that 2 electrons filled in 1s orbital. Okay, and next. So like this they are asking in a reverse way also. So 1s2 they are giving and then asking what is the value of n and what is the value of l, and so 2 electrons are present. Next, to fill these electrons in the orbits, we have to follow 3 rules. So first rule is Pauli's exclusion principle. So what he stated in this. So what he stated, no 2 electron can have all 4 quantum number same. Means for any 2 electron, for a pair of electron can have 3 quantum numbers same, but at least 4th quantum number should be different. Let me see the same example. 1s2, helium atomic number 2, no? Electronic configuration 1s2. Let me write the 4 quantum numbers. First quantum number n. Now only we discuss n value 1s2. So n value is 1. Okay, and we know for s orbital L value 0. And ml, third one is magnetic quantum number. ml formula 2l plus 1, no? So you keep 2 into, in the place of L, you keep 0. 2 into 0, 0 plus 1 means 1. So that is only 1 orbital containing. Now coming to 4th quantum number, ms, spin. So in helium, it contains 1s2, means 2 electrons. So for first electron plus half, and for the second electrons minus half, means 1 electron clockwise direction and another electron in anti-clockwise direction. If you observe, for these 2 electron, for this pair of electron, these 3 quantum numbers same. Why? It belongs to same orbit, it belongs to same cell, and 2 electrons are included in the same orbital. So that's why maybe these 3 same. These 3 means these 3 quantum numbers same, but a 4th quantum number should be different. So this is the best example to explain this principle. And the second principle is Harbor principle. What he stated. So Harbor principle. What he stated in this. Here, he stated that electrons will be filled in the orbitals which is having lower n plus l value. The orbitals which is having lower n plus l value, so that will be filled first of all. N plus l value. N represents principal quantum number, means which orbit? L subcell. L value is 0, S 1. P orbital 2, d orbital, like that. So first of all you have to calculate n plus l value and have to see which is having lower n plus l value. That will be that. So first you should write the orbital first of all, and in that only electrons should be filled first. And you will get one more doubt. Teacher, so if two orbital having the same n plus l value, same n plus value, I will give one example to that. For example, 3D and 3D and 4F. So for 3D n value 3, L value, L 0 means yes, 1 means P. For this 2D, so D value 2, that is 5. Okay, 4F. For this 4F, n plus L value, n value 4, L value 3. So 4 plus 3, 7. So which orbital will be filled first? So which is having lower n plus value. So according to that, first 3D orbital will be filled. And the next, so if it containing same value, n plus l value, same n plus value. For example, 3D and 4P, let me write. So for this 3D and 4P, for 3D now we have written n plus l value, n value 3, L value 2, means 5. For this n plus l value, n value 4, and for this P value is 1, means totally 5. Now see, same n plus l value, then which orbital you will write first? So then you need to check the orbit n value, which orbital having lower n value, that only filled first. Okay, so that is stated by above. So one more principle in this, Hund's rule. So pairing of electrons takes place after filling the degenerate orbital half. So let me take carbon as an example for Hund's rule. So for this 1s2, 2s2, 2p, 2 we are writing the electronic configuration for carbon. So see here for 1s2 electrons, for 2s2 2 electrons, and so 4 over fifth electron, it first of all goes to px and then to py. Why? You know, pairing should not be takes place in px orbital only. According to Hund's rule, what he stated, no, electronic pairing takes place after all degenerate orbitals are half filled. Degenerate orbitals means, this is very important question. So the orbital which is having same energy, px, py, pz, these three we call it as a degenerate orbital which are having same energy. And one more here, so they are asking electronic configuration of copper and chromium. Copper 24 and copper 29, chromium 24. So let me write the electronic configuration of copper. 1s2, 2s2, 2p6. Totally how many? 10 over. Okay, next 3s2, 10 plus 2, 12 completed. Next, which orbital will come 3s after 3p? 6. So totally how many? 18 over. Okay, 18. Next, 4s. 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 In 4s, how many electrons should be filled? 2. So totally 29. Next. So next, which orbital will come? 3d, depending on n plus l value. So in this 10 electron can fill. 10 electron can fill. Now let me check. So totally how many here? 10, no? 18, 20. 20. Here 9 can fill. Like this it should be. The copper electronic configuration should be like this. Okay. But we have to write the electronic configuration like 4s1 and 3d10. Okay. So in the same way, chromium 1s2, 2s2, 2p6, 3s2, 3p6. So 10, 18. 18. So here 4s and 3d. So in this we can fill 2 electrons. Then totally 20. 4, no? 4. So but we write like this. 4s1 and 3d5. So what's the reason, you know? Half filled and completely filled orbitals are stable, more stable. So that's why we write the electronic configuration like this. This is a peculiar electronic configuration. Okay. So and this question is repeated many times. So prepare well.